recording on another example regarding limiting reagent. Okay, so that's going to help you, though this example is going to help you to understand the process thoroughly. Okay, let's have a look at what the question is. In this case, you've been given a chemical equation, nitrogen reacting with hydrogen to produce ammonia. You see the ratio 1 to 3 to 2. Okay, now as you can see, you've been given 5 moles of nitrogen and 6 moles of hydrogen. The question is asking you to find the number of moles of ammonia that is going to be produced. And the second one is find the number of moles of excess. Now, by looking at this question, you know that this question is going to be based on a limiting reagent concept. Why? Why? Because you've been given the number of moles of the both reactant. In the normal stoichiometric question, you only get the number of moles of one reactant. Then based on that, you will be asked to find the number of moles of the the number of moles of the product. But in this case, you've been given the number of moles of both reactant, and the question is asking you to find out the number of moles of the product. Therefore, we have to, our first step is to find what the limiting reagent is and the number of moles of the limiting. Is that clear? So let's do step number 1. Step number 1 is to find what the limiting is. Okay, so how do you find the limiting reagent? In order to find the, what I'm looking at, I'm looking at the top. In order to find the limiting reagent, what you need to do, you need to get the number of moles of each. In this case, number of moles of nitrogen, that is given to you as 5 moles. Okay, 5 moles. Now divide that by the coefficient. Coefficient is 1. So 5 divided by 1 is 5.0 moles, right? Okay. Now then get the number of moles of hydrogen, which is 6. All right, which is 6. 6. Yeah, we are doing this step to find out what the limiting is. Okay, divided by the coefficient is 3, so that is 2.0 moles. Now as you can see, out of these two numbers, which one is smaller? Compare 5 and 2. 2 is smaller. 2 is smaller means our limiting reagent is the, or reactant is the hydrogen. Is that clear? Our limiting reactant is the hydrogen. All right. Now listen. You found out what the limiting reactant is. So write a statement saying, therefore, limiting reactant is hydrogen. Now after you have found out what the limiting is, go back to its original number of moles, because what matters is its original number of moles. Okay, we are not going to use any of these numbers, especially any of these numbers for our calculation, because we do this step just to find out what the limiting is. Now I used to call this a box method, because whatever you write in step 1 is written in a box, so that we are not going to, or we don't end up using these numbers 2 and 5. Okay, we always, after you have found out what the limiting is, you always need to go back to the limiting's original number of moles. I repeat, limiting's original number of moles. Is that clear to you? All right, now we got the limiting and we got the limiting's original number of moles as 6. So what are we going to do in step 2? Let me get another pen. In step 2, this one. In step 2, what we are going to do, we are going to use our number of moles of limiting to find out the number of moles of the product, which is ammonia. So you have to set up the ratio between unknown of number of moles of ammonia over number of moles of known, which is the limiting, which is the hydrogen, right? The ratio is what? 2 to 3. Okay, therefore number of moles of ammonia produced going to be based on the number of moles of the limiting or the hydrogen. 2 over 3 times number of moles of the hydrogen. You know that 2 over 3 times what's the number of moles of hydrogen? Original 6.0. So as you can see, there are 4 moles of ammonia are going to be produced. So in other words, number of moles of ammonia produced is 4 moles. That's done. Simple. Now, next question is asking you to find out the number of moles of the excess. Okay, what is the excess? As you can see, our excess is the nitrogen. Now, the question is asking you to find out the number of moles of the nitrogen. Number of moles of nitrogen, leftover number of moles of nitrogen. The question is asking you to find out the leftover number of moles of nitrogen. In order to find that out, or before you find that out, you need to find out the number of moles of nitrogen used, consumed with these 6 moles of hydrogen. Is that clear to you? In other words, what is the number of moles of nitrogen that is used once we use all these number of moles of limiting reagent or limiting number of moles or the hydrogen number of moles. Is that clear? So in order to do that, step 3, what do you need to do? We need to set up the molar ratio. Step 3, to find out the number of moles of nitrogen used. So I am going to set up the molar ratio between number of moles of nitrogen to number of moles of hydrogen. That's the limiting, right? The molar ratio is 3 to 1, isn't it? 3 to 1. Therefore, number of moles of nitrogen used is going to be, and I'm looking down too much here, is going to be 3 over 1 times the number of moles. I think I might missed it here. That is ridiculous. Sounds ridiculous. This cannot. This is wrong. Yeah, it should be other way around. Sorry. So it has to be 1 goes here, 3 goes here. Man, okay, that's a mistake. Do you see the mistake? You did not tell me, did you? You should have told me before I made that mistake. While I was making that mistake, you did not tell me. Okay, now let me cross this out. Therefore, number of moles of nitrogen used is 1 over 3 times the number of moles of hydrogen, which is the number of moles of limiting. In this case, 1 over 3 times what's that? 6. Yeah, 6. This is 6. So in other words, 2 is the number of moles of nitrogen used. So we have used 2 moles of nitrogen. Then the next one is therefore number of moles of the nitrogen in excess, so the leftover excess is going to be, you started with 5, you used 2, okay, where did I get 2 here? Okay, yeah, 3 over 1 makes sense. 1 to 3 times it. Okay, I just want to make sure, double check. 5 minus 2, so if we had 5 to start with, you end up using 2. 2 times 6, yeah, that's correct. Then you got 3.0 moles of nitrogen will be left over or going to be in excess. All right. Hopefully this time I'm going to save it properly. I don't want to do this again. Okay, I might do another example where you are going to be given the masses of each instead of moles. So simply what you need to do in that situation, you need to convert into moles and then do the same thing over and over again. All right, that's all for now. Thank you so much for watching and learning. Love you for loving chemistry. See you. Bye.